So now I am going to show you how to set these imaging parameters on a 96 well plate using the software on an actual system. First, you want to access your list of plates in Gen5. And then the question is, what is the right starting point? What you can do is either try to find your specific plates in a database. If you know the brand or if you know the part number, you will likely find it in the database. If you don't, or if you're unsure, a great place to start is the plate that is provided with the software that is called 96 well plate SBS dimensions. This is the actual standard XY definition of a microplate that will fit any of the major brands. So I'm going to select this plate in the list, and then I'm going to select copy. You do not want to modify the existing microplate because that definition might already be in use by someone else. You want to make a copy and use it as your own. So I'm selecting copy. And the first thing I'm going to do is rename this plate as my own. So I will give it my name, Xavier 96 well plate. This way people will think twice before modifying that one plate that has your name used as a tag. All of the XY parameters, as I told you, are defined as a standard, and you really do not need to change any of those. The only thing that we need to look at right now are the imaging parameters that I'm opening right now. And we're going to look at how we set this important bottom elevation parameter. What I'm going to do now is put my microplate in the instrument. It's an actual plate that contains sample to adjust bottom elevation. You need good quality microscopic samples that you can look at, because what we need to do now is focus our optics onto that sample. So to check the bottom elevation, I'm now going to click on this little icon right next to the box that is going to launch the system's manual mode interface. The name of the plate hasn't been updated. It will be updated when you save it, but you can click OK right now. And really here your only goal is to get an image in focus. Once you're done, you're all set. And so this is what I'm going to do now. On this system, I only have a 4x objective. On your machine, you will want to select the lowest magnification objective that you have on board. This will make the process easier. The second thing that you want to do is select the imaging channel. Here I'm going to select GFP because I know that my sample is bright in a GFP channel, and that will make the process easier. Finally, in this microplate, I know that A1 has a good quality sample. On your microplate or your sample, you might want to select whatever location has a high quality sample that you can image easily. Now we are looking at the live feed coming back from the CCD camera, and as you can see, there is no image. As I said, your purpose here, what you want to do is get an in-focus image, and there are several ways to do it in the interface. The easiest way is to click this button here called Find Image. This button will automate the process of autofocusing while also adjusting camera exposure. It's a very reliable routine, and it will work most of the time. As you can see here on the screen, the system has found my cells, and they are in focus, properly adjusted. And you can see here the current Z position on the left that is around 3200 microns. I can set this as my new bottom elevation by hitting the button Save Settings. And if that works as well as this, you're done. If you cannot find your sample here because the Find Image function doesn't work quite well, let me show you another strategy you can use. I'm going to set my Z height to a different location here to be far away from where the sample actually is. So as you can see, my sample disappeared pretty much from the live feed. And I'm going to use this function here called FM scan. FM stands for focus metric, and that is the metric that the machine uses to see how far away it is from focal plane. If I hit FM scan, the system will automatically start scanning your sample in the Z direction, looking for the best contrast in your image. And as you can see here, the curve is climbing from left to right, which means that right now we're getting closer and closer to the optimal focal position. So I'm going to let the system go through this. Right now it's going from a range from 2200 to 2800, and as you can see we didn't reach a peak yet, and what you want is a peak. So I'm going to select set focus height to maximum FM ratio. As you can see, my height is now set to 2800, and I'm going to do another FM scan. And you can repeat this process until the machine finds a peak within the Z area that it's looking at. And it's possible that it's going to happen on this scan. If it doesn't, we will do it one more time. So as you can see, I don't have a peak yet, so I'm going to go through that process one more time. I am going to select set focus height to max FM ratio, which is setting my focus height to 3100 roughly, and I'm going to do one last FM scan. This process that I'm going through right now, you would really only use if you have a hard time finding your cells or your sample. Usually it's pretty easy to find them by playing with the focus manually, but if you have a hard time, this is a great way to do it. And as you can see here, we have found a maximum, and the system here is showing you what is the height you should set your objective at to get an in-focus image. Again, I'm going to click that button here, set focus height to max FM ratio. My image is in focus. I am going to click Save Settings, and when I do this, my Z position, my current Z position is saved as my bottom elevation. It's an easy process, but I'm just showing you here a few strategies that you can use to find an in-focus image. Once this is done, you're all set. You can save your plate definition, and you should be in focus all the time in a way that is repeatable. The other parameter that we talked about earlier is this one here called bottom thickness. Here what you need to do, if you're not sure, is contact your microplate provider and have them tell you what is the bottom thickness on the vessel that you are using. Once you have this number, you can just enter it right here. In that case, I'm using a plastic microplate. The bottom thickness is 500 microns. And remember that if you want to use this microplate with a high magnification objective, you will have to set your correction color to the corresponding number, in that case, 500 microns. So we're done. We went through the process of setting the bottom elevation parameter, which is by far the most critical. For high magnification microscopy, I set the bottom thickness. And now you will see that when I close my plate definition, I am back to my list. You will see that here my own plate definition is in the list. It's actually defined by default as a favorite, which will make it easier to find when you actually want to run the system. And you can go through the same process, exactly the same process, for any kind of sample definition. So here we did 96 well plate, but you could do the same for a slide, you could do the same for a 24 well plate. And once you know how to do it, it's a very easy process.